sheet that related to those climates over the last 20 million years.
We will drill 6 sites in total, 4 from the shallower continental shelf and 2 from the continental rise.
This expedition, Expedition 374, is going to really advance our understanding of not just the Ross Sea, but West Antarctica as a whole.
The JOIDES Resolution, an IODP ship that drills cores from below the ocean floor for science, is currently transiting across the Southern Ocean. In a few days, the expedition will reach its first drill site. Then, for the 31 scientists, 22 technical staff, and 63 crew on board, it'll be all stations go. Follow our journey at joidesresolution.org.
So each IODP expedition costs about 12, help! And now $12 million. Ours cost a little bit more than that, and the US puts in most of those funds. So here we are in Lyttelton, New Zealand, and we transited to the Ross Sea here in the Antarctic. It took us 8 days to get there, and those who get seasick weren't quite as happy as people like me. When we got to the Ross Sea Polynia, we met up with the icebreaker, the Nathaniel B. Palmer, that guided us into the Polynia. They were worried about sea ice. However, as you can see from this picture taken from the Palmer, there wasn't much sea ice. So we didn't actually need the icebreaker. There you go, Maya. There it is. We saw lots of wildlife. We did some science talks, prepared to start drilling. We worked 12-hour shifts every day. So we drilled 5 sites. We did not drill 6 sites due to a technical difficulty. We drilled 2 on the shelf and 2 on the, well, 3 on the shelf and 2 on the rise here in the Ross Sea. Just the basic simplified physical oceanography here, which is important to some of our sites. We have circumpolar deep water that impinges up on the coast here. That's warm water that is derived from North Atlantic deep water and a mix of other waters. We have this slope current, which runs along the slope, and that strength of this current through time dictates how much of the circumpolar deep water is allowed to upwell onto the shelf. We also produce in the Ross Sea some of the majority of the Antarctic bottom water that travels at depth northward and constitutes a majority of the deep ocean waters. And so that cascades off the Ross Sea shelf and into the deep here, and that influences our sites. So one of our grad students, Imogen, sailed with us, and here she is, hopefully. I totally included this, Imogen. If you guys as grad students ever get the opportunity, you should do one of these videos.
My name is Imogen Brown, and I'm a Fulbright student from New Zealand studying my PhD in marine science at the University of South Florida. And I'm here in Antarctica. So we're on a boat called the JOIDES Resolution, which is part of the International Ocean Discovery Program. And what we're going to be doing is recovering marine sediment cores from beneath the sea floor. And we're going to use those sediment cores to understand how West Antarctica has evolved over the past 20 million years or so. So the drill core is just behind me, and this is where cores come on deck. Techs will bring the cores into this area, and they'll be laid out on these tracks here. And then they'll be cut into 1.5 meter sections, and that's where me and my team come in. So we'll go inside. So here we have one of the 1.5
Team and
I that we've brought in from outside, and my team is trying to get a first order look at the physical properties of the core. So we're measuring things like radioactivity, magnetics and velocity of sound through the core. So once we have the split cores, we then take a small amount of sediment, and what we'll do is we'll weigh this. So on the left here I have a reference scale, and on the right an unknown scale. One will calibrate the other, and so that is how I know what the weight of this is, even on a moving ship. So after we've measured the physical properties of the cores, we then split them and we bring them over here for a sediment description. So what we're looking for is changes in color, changes in grain size, and these things might tell us about past depositional environments, which we can use to tell us something about ice sheet history of Antarctica. So we can look at the sediments to understand how the ice sheets have advanced and retreated over millions of years. And this is really important because we need to understand this process to be able to model what's going to happen in the future.
I also was on the boat in 2000 as well. See, I look the same. So here's the JR. Drilling conditions were tricky. I know I'm running late. This is the moon pool where the drill string reaches down to the seafloor to take our samples. And here is a video of the first piston core at our site firing into the sediment to collect that sedimentary record. We'll then drill down 10 meters and fire the next core. So pretty cool. You can see the core liner here, and that will be brought up through the drill string and back to the ship so that we can describe it. So these sediments can tell us a lot about the depositional environment. These are some of the sediments that we collected on the ship. These are this ice rafted debris. There are these little turbidites or downslope flow, which is going to tell us a little bit about the history of bottom water cascading off the shelf. This is a channel deposit, so a conglomerate. And these are the trace fossils of organisms that used to live in the sediments. Some of you may recognize a geotraces character there. So what I'm really interested in is these warm periods of climate, like the Pliocene and the Miocene, and we want to understand how these warm periods influence the Antarctic ice sheet. So the site that we're going to be focusing on is the site 1521 on the shelf. This is the seismic record from it. It kind of looks like a mess, but our target was to understand what age this unconformity was here. So this gap in time that we can see in the seismic record. So this is the section that we drilled. Oops, hold on, get through all that. And so this is site 1521. This is the amount of recovery in each core. And basically what we've recovered was an expanded early to middle Miocene section. So 18 million years to about 14 million years here. And this shows glacial advances and retreats from the continental shelf and prolonged open water in this Miocene climatic optimum when it was warm. So this is a record of mixing of sediments by glaciers. This is diatom ooze, and this is diamict. This is diatom preserved, and these diatoms and these forams are going to help us to understand the age of the sediments, and that's just other pretty sedimentary structures. And we found some shells as well in this site. And so these sediments suggest that, you know, at this site, it's 17 million years ago, the system may have looked like this. Whereas at the Miocene climatic optimum peak, the same system may have looked a lot like this, which is a lot different than Antarctica looks right now. So post-cruise, we're going to be studying the forams and Tex 86 in the sediments to try to understand ocean temperatures through time. Did the ocean temperatures influence past ice growth and retreat? So I can't tell you a lot about what we found, but I can show you this. These are all the sedimentary sequences we recovered from the 5 sites. And here is that record of the oxygen isotopes showing the global climate signal. these boxes which aren't showing up. This is the Miocene climatic optimum here, and this is Pliocene warmth here. So we have some really exciting records across those warm climate intervals. Every day was beautiful. So in summary, we drilled 5 sites. We recovered at 1.3 kilometers of core. This is the highest ship-based recovery from the shelf, 63%, and that is fantastic. Here's a summary of what we kind of found at each site. Some really exciting science to come in probably the next 10 years. We also did a lot of outreach events, and you can see some of those. We did blogs, our classroom exercises. You've seen some of the videos, and you can find those on the social media for IODP. So we had to return early because of a failure in the ship. The prop shaft was leaking. It is now in dry dock to fix that. And just to conclude, we couldn't have done this without all of the Expedition 374 scientists, our co-chiefs, and our staff scientists. 13 countries are represented. This was a more than $12 million leg. What I wanted to point out, too, for all of you women in the room, so DSDP Leg 28 in 1973 had 2 women. Here they are. So IODP Expedition 374 in 2018 was 49% women. And here we all are. And that was actually, IODP is trying to introduce parity into their science party. And we were, to date, the most successful at doing that. So there we are.
Who were the 2 women in 73?
Liz Truswell, who is a pollen expert, and I can't remember who the other one, she was a sedimentologist. I can't remember who she is. And so thank you. I know I ran a little bit over. Sorry.